With the advent of new space economy, the number of satellites orbiting the Earth is increasing, exacerbating the space debris issue. Thus, a cheap and robust propulsion system to deorbit satellites is becoming urgent. Our answer is Regulus 50A2, a compact electric propulsion system specifically designed by T4I for small satellites. Designed with a plug-and-play philosophy, Regulus uses solid iodine as propellant that is green and allows for a compact design. The solid iodine is already included in the fluidic subsystem, ATILIUS. However, the first Regulus design cannot provide enough propellant to allow both nominal operations and the orbiting of satellites. For this reason, Optimad, Hydro and T4I decided to redesign the fluidic subsystem within the ATILIUS project. ATILIUS project aims at increasing the Regulus 50A2 tank volume by 3.5 times, optimizing the printability of tank and the manifold to reduce environmental impact, increasing the thermal efficiency of the system by numerically modeling the sublimation of iodine within the tank, establishing the environmental impact of Regulus 50A2 with a life cycle assessment and study strategy to reduce it. This work will result in design and sustainability guidelines for the additive manufacturing processes that will help designers to implement a new design approach in the framework of circular economy. We started from the design of the main components of ATILIUS, namely the manifold and the tank. The tank has been designed with an increased capacity to allow further orbiting. The printability of ATILIUS has been optimized to reduce post-machining time and wrong prints, thus reducing the environmental costs. The design also considered the thermal efficiency of the system, thanks to the numerical model developed by Optimad, capable of simulating the sublimation of iodine within the tank. Using recycled powders, the ATILIUS subsystem was then manufactured by means of laser powder bed fusion (AM) in Hydro premises. The result was a new ATILIUS subsystem that has been integrated and successfully tested for functionality and robustness. The whole manufacturing process has been monitored thanks to the LCA simulation engine provided by KYKLOS 4.0. This instrument allows for the calculation of the environmental impact of a device in each stage of its life. Easy to use and user-friendly, it is possible to add every process from the menus, material used, and also simulate life and the end of life. Thanks to this instrument, the consortium produced the complete LCA of ATILIUS, showing that it is possible to reduce the production of CO2 of more than 25% by using recycled powders. The new design of ATILIUS features a circular inflow of 96.7%, meaning that almost the 97% of the material used came from recycled parts, contributing to circular economy goals. As a comparison, the old design used just the 32% of recycled materials. Moreover, the wasted material will be recycled to become new powder.